Hello students, let us see this question here. A loop of flexible conducting wire of length L lies in magnetic field B, which is normal to the plane of the loop. A current is passed through the loop. Right, the tension developed in the wire to open up is. So it is asking the tension T develop. So let us call, right, a mistake. So let us call this is uh, T here. So the tension T developed in the wire, right, in to open up. This I need to find here. So suppose I take one cross section of, so what will happen? So let us take the small elementary of this circular wire like this. Okay, and suppose this is the center. So the tension will develop here. So let us take the tension is acting in this direction, and here also the tension will act in this direction. Right, this is the elementary length of the circular wire. So this angle will be very small. So let us call this angle is d theta here. Okay, now here the force will act in outward direction, and that this length is dl. So that will be so let us call the magnitude of magnetic field is B. So B is the magnitude of magnetic field. This length is dl. So B dl. I and the current is suppose I. So I B dl. So that will be the value of magnetic field in outward direction. Right. Okay. Now this elementary length of the wire must remain right. The total force on this elementary length of the wire must be balanced. So if I take this line, so this angle will be d theta by 2. Okay, and similarly here, if I take, so this angle will also be d theta by 2. Okay. So now, right, this tension will have two components. First is the horizontal direction and second is vertical direction. So let us take the components here. So this component will become T cos d theta by 2. Okay, and this component will become T sin d theta by 2. Okay, similarly here, if I take the component of T here, so this angle will be T cos d theta by 2, and this component will become T sin d theta by 2. Now, right, so if I take the ABD of this elementary wire, right, this elementary length of the circular wire, okay, so the forces in the horizontal direction will remain balanced because T cos theta by, d theta by 2 and T cos d theta by 2 will cancel out each other. So upward force must be balanced by downward force. So from here I can say, right, B dl I, right, must be balanced by these two forces, that is 2 times of these two magnitudes are equal, so that will become 2 times of this, so that is 2t sin d theta by 2. Okay, so from here I can say that, right, that will become B I dl, and that is 2t, right, since angle is very small, so sin d theta by 2 must be equal to d theta by 2. The reason is, right, because the d theta is very small, very small angle. Okay, now these two will get cancelled out, and from here I can say B I dl upon d theta will be equal to t from here. So from here I can say bi. Now this dl must be equal to r d theta. Right. So that will become r d theta, and this will become d theta, and that is equal to t. So this will get cancelled out, and from here I can say t will be equal to b I r. Now, okay, now it is saying the flexible conducting loop, the flexible conducting wire of length. So wire is having the length as L. So whole circle is having the length as L. So I can say 2 pi r, where r is the radius, so that must be equal to L. So from here I can say r will be equal to L upon 2 pi. I can put the value of r in this one. So from here I will get, that will be b I, and r is equal to L upon 2 pi. So L upon 2 pi. So this will be the answer. So let us see which option is matching here. B I L upon 2 pi, BIL upon 2 pi. So that is the option C here. Okay students, I hope you understood this question.